So addition, subtraction, so far so good. Multiplication, division though, we have to treat differently. And you'll see why in a second, right? So for multiplication, if I take my complex numbers again, a plus bi and c plus di, and if I was to multiply them together, right, what does that kind of look like? What does that remind you of? Yeah, it kind of looks like a binomial expansion, right? I'll make that. All right, this kind of looks like a binomial expansion, and in some sense we can treat that as doing a FOIL expansion, yeah? Which ends up being, well, what does it end up being? Because like you guys realize, we do have I in this situation. So let's just do it out just to see what we get, right? We'll get AC plus ADI plus BCI. And then here we get BDI squared.
Oh, yeah.
Okay. What can we do with that? Okay, so we can recognize that, hey, we have some identities. I squared is going to be -1. We can put that in. And so when you think about it, what are you actually doing here in this situation now? If you like, what you can do is you can kind of rearrange this in a way so that we have, how should we rearrange this? We can, yeah?
Like a funky quadratic.
Yeah, it is kind of like a funky quadratic. One thing we kind of like to do with complex numbers is group, because remember, if we're multiplying this out, we're kind of expecting to get a complex number as well, right?
AC minus B.
Right, yeah, we can have, hey, there are real parts here, AC minus BD. These are the real parts of my expression, or my complex number. And what are your imaginary parts? Well, they're AD plus BC, all multiplied by R, yeah? So that's how we can think about multiplication. We can think about it as expansion, but there's also a formal definition as well. And so that makes solving the problems, again, familiar, right? Here's your first one. If we were to simplify this guy, we can treat him as we would with multiplication of expanding brackets, yeah? So we've got 3i times 3, that would be, why am I using different pens? That would be 9i. And then just being careful with the identities we already know, 3i times -i. Again, just if you're not too sure, we can write it as 3i squared, but we recognize that this is actually -1, yeah? And generally, like, they write the real parts first. That's just like a convention thing, so up to you.
Well, you just expand it.
Yeah, nice.
So, what? -1 minus 5i?
-5, yeah, let's just expand it out, just double check. So we get 2,
Yeah, that's right.
it is? Should I trust you guys? -3i, -2i, plus 3i squared, and -1 minus 5i, nice. Which brings us to, I think you guys will be fairly okay to keep going and trying those examples out yourself, and you've got some problems like that. There is one rule to look out for when you're looking at your expansions. You guys had shortcuts to do, right? You had like perfect squares, you had difference of 2 squares and things like that. Because of our imaginary unit, that's going to be slightly tweaked now for these ones. But I'll let you guys work that out yourselves when you try those problems. It'll become apparent.